Hi everyone, I'm Prasanth Kosaraju, a network engineer with over a decade of experience in designing, deploying, and securing large-scale network infrastructures. I've worked on everything from enterprise LAN WAN setups to data center networking, wireless optimization, SDN integration, network automation, and zero trust security architectures. So my main focus is on building reliable, scalable, and security systems for telecom, industrial control, and education networks. So today I'm thrilled to be here at Conf42, and a huge thanks to Mark and his team for this opportunity to connect with such an amazing global community. Today we are diving into why Rust programming language is transforming network infrastructure. We'll explore how Rust delivers unmatched speed, safety, and reliability for critical systems. Let's get started. So here's our roadmap for today. We'll see introduction to Rust for networks, like why Rust is a game changer for network engineering. And then we'll go through some Rust-based network architectures, how it's built, layered, and tested with all the durable components. And then we'll go through the SDN integration and optimization techniques using Rust. And then we'll see how AI-driven monitoring and tools are aligned and synchronized using Rust. And then we'll go through some zero trust security implementations. And last, we'll go through some case studies and a few takeaways and key things regarding Rust. So why Rust for network infrastructure? Rust is revolutionizing how we build networks. The thing is, here's why. Number one is memory safety and also the fast performance. And then coming to the concurrency safety, and also the compile time, which guarantees Rust is the best in the current networking world. So coming to the memory safety, Rust ownership model and borrow checker eliminate bugs like dangling pointers, use after free errors, and data races. This ensures predictable behavior even under intense multi-threaded workloads. It also Rust zero cost abstractions, delivers C++ level speed, ideal for latency sensitive tasks like packet processing, where every microsecond counts. And then coming to the concurrency safety, Rust do handle tens of thousands of simultaneous connections without risking undefined behavior, which is like perfect for load balancers, proxies, and SDN controllers. And then we'll see the compile time, how Rust is different from other programming languages. So it's a strong static type ecosystem that catches protocol and configuration errors before they hit production, reducing the runtime failures. So Rust ecosystem with tools like Tokyo, Hyper, Tonic, and Twin makes it practical to build high throughput, basically production grade network services. And also adoption of using Rust has been surged in the last 3-4 years in telecom, in data center sectors, and also some industrial control over the past few years. And Rust is also good for maturing support for SDN, telemetry, and zero trust frameworks. Some might ask, why not stick with C or C++? Rust matches the same speed, but it adds more safety built features, and also it's critical in infrastructure where downtime isn't an option. So what is the Rust-based network architecture and how it works? Rust let us build in modular type-safe network architectures that are robust and scalable. Let's say like type-safe configurations. We use compile time validated templates to prevent misconfigurations before they even reach the network. So in layer 2 or layer 3 switching, we use a deterministic approach, and then the resource allocation ensures low latency performs under heavy loads. And then coming to the wireless optimization, Rust powers MU algorithms for real-time channel allocation, and also it maximizes the throughput. And the last but not least, it's the latest as the Cisco cloud-based platforms like Cisco Meraki or Cisco FMC. You can use in monitoring tools as well. So Rust async capabilities via Tokyo deliver real-time visibility and gives better control across the infrastructure. And some might ask, what is the measurable impact? We have recently deployed in a large-scale modernization project for NYC public schools, where we have seen Rust-based provisioning scripts for 40% faster than the traditional setups, and it made a significant boost in deploying efficiency. Coming to the next one, which is the SDN integration and hybrid cloud, like how Rust is aligned with this. So Rust shines in software-defined networking and hybrid cloud environments. So the dynamic provisioning, Rust Tokyo async runtime enables non-blocking and eliminates any bottlenecks during the resource allocation and reclamation. And coming to the traffic optimization, it is the best for precise timing controls, ensuring the QoS policies like the quality of service, prioritize latency sensitive applications like video streaming are critical networks like SCADA or BMS or Delta V networks. And also the seamless security, which is the top tier in Rust. It's basically zero cost abstractions, power VLANs, and 802.1x authentication, balancing robust protection and high performance. The 802.1x authentication we can definitely use in Cisco ICE, or we can align with Cisco Umbrella as well. So Rust scripts do support with Cisco ICE and also Cisco Umbrella. So by integrating everything with the SDN controllers like ONOS or Open Daylight, Rust do enable automated provisioning, intelligent traffic engineering, and rapid reconfiguration. And then coming to the next tech, which is the AI-driven and monitoring and analytics. So we'll go through like how Rust works in AI monitoring and tools. So Rust machine learning ecosystems powers real-time analytics with minimal latency. And the anomaly detection is very fast and accurate within the systems that catches the issues before they escalate. So rather than an issue triggering after a day or a certain amount of time, Rust will simply triggers the alert, and then you will get instant alert, and then you can be on top of it. And then also the automated audits. Rust compares live configurations against baselines, streaming telemetry via SNM VV3 and NetFlow. And also the predictive analysis, forecasting minimizes false positives and supports smarter city planning and also smarter capacity planning. So Rust's ability to process high volume data streams in real time turns insights into immediate action, which is a great beneficiary to all the networking people. So the next one is the zero trust security, like how Rust is changing it. So as everybody knows that what is zero trust? Zero trust is basically never trust, always verify. So Rust makes it practical. We use the microsegmentation, VRF Lite and TrustSec backed by Rust type system, which ensures configuration integrity. And then we do use the identity-based access, which is the 802.1x and certificate authentication, coded in memory-safe Rust, and eliminate common attack vectors, where this is one of the key sections like identity-based access. We can definitely use a Cisco ICE, Identity Services Engine, or we can use Cisco Umbrella, where the external networks or where the external vendor is trying to get into your network. That's where Cisco Umbrella comes into picture. And the Cisco ICE, where it's the endpoint security for your organization. Like it can be your phone, it can be your laptop, it can be any Linux workstation or any operating device within your organization. And the next thing is the encryption. So we use the TLS and IPsec tunnels, which uses formally verified Rust cryptography libraries for proven security. And on top of that, we have the continuous monitoring capacity where lightweight threading enables constant trust evaluation without the performance hits. So tools like Zscaler integrate seamlessly with Rust-based components, ensuring robust and high-speed security. So now we'll go through some case studies, the case studies from the educational system. So we have deployed recently in a couple of boroughs in New York City, around 75 locations where we have successfully pushed to 50,000 endpoints. This is a 1:1 initiative program for classroom connectivity. And we have segmented all the VLANs for admin, student, IoT, and all the other critical devices. And these were isolated through security policies by using Rust. And the results we see are like 99% uptime. And we have seen a 47% reduction in security incidents. The provisioning, which is a key factor, 78% provisioning time, which is like really good. And then even the bandwidth utilization, we have improved a lot, which is like much better than our previous legacy infrastructure. So Rust delivered the reliability and efficiency at its scale as we expected. And then the next one is in a different industrial facility. This is a biotech firm where we have built cyber resilient networks or the enterprise cyber resiliency, ECR. So we have used the VRS based segmentation and redundant pathways, determining the performance and also the backups. For this, we have seen the results are similar as expected. We have zero successful cyber intrusions, and then we have the 99% uptime, and the maximum latency we have seen is somewhere from 20 to 15 seconds for critical controls, which is like really good. So here in this case, Rust did ensure mission critical reliability and security as well. And then some might be asking what are the implementation challenges that we have seen without hurdles. Like basically adopting Rust isn't without hurdles. So the legacy integration, older systems often lack modern APIs, as everybody knows. So Rust capabilities safely wrap legacy code, extending its lifespan, and also the resource constraints. Incremental rollouts prioritize high impact security components for early. So you need to make sure you have to determine the approach when you modernize your network infrastructure. You have to make sure you have a clear picture of all the end of life devices. Try to evaluate and then slowly deploy using Rust. You can definitely see the results. And also the evolving threats in the current infrastructure trend, the modular architectures allow targeted patches and updates without downtime. So Rust flexibility definitely helps you over time and also overcome these challenges effectively. And here we see the performance metrics. We can see the Rust-based implementations have been outperformed by traditional architectures. Here you can see a lower resource usage, reduced memory and CPU load. Here we can see a faster processing, a decreased requesting latency and higher throughput. And also you can see the cost savings. A leaner footprint supports a seamless scalability. These gains obviously translate into a tangible operational and financial benefits for your organization down the line as well. And then here, what are the key takeaways and the important things about what we are learning in Rust programming infrastructure is Rust is definitely a game changer for network infrastructure because of its safety and performance, because the unmatched memory and concurrency safety with C-level speed, that's undoubtedly better and good results. And also the type safe configurations, which can prevent errors before deployment rather than during the deployment and causing a huge outage. Rust can definitely evaluate everything in a sandbox environment and do give you an upper hand in the visibility. And also coming to the zero trust, we have seen its practical high-speed security and it's proven. And also coming to the AI-driven operations, its proactive monitoring and analytics have given you an upper hand on this as well. So the next steps obviously will be how you assess your current infrastructure and also identify the critical and high impact components for Rust adoption. Plan in a phased migration strategy rather than jumping in the fly and causing any issues. And also start with monitoring for immediate visibility gains, like trying to have monitoring tools, let's say for any bugs or any power alerts or any high throughput or any CRC or bandwidth errors within the uplinks or within your optimization. To wrap up, what I can say is Rust do empower us to build network infrastructures that are fast and securable and also maintainable from education to industrial systems. We have seen measurable results like higher uptime, faster provisioning, and stronger security. So I would like to connect further to discuss more on Rust-powered networking, share my insights, and also tackle any real-world challenges. So thank you for your time and attention.